Welcome to all the beloved viewers. As SUBBA, student of NAMCHI Govt College KAMRANG, BSc Physics of 3rd semester, is here to give a presentation on Lorentz transformation, time dilation, and length contraction. I would also like to give a sincere gratitude to Dr. C.P. Khateura sir and to all the professors of Physics Department for providing us such an opportunity to express ourselves. So without wasting any time, let us start the video. So in this video, I will explain you about Lorentz transformation. So first of all, we should know what is meant by transformation. So here you can see a portion, this portion A and this is portion B, which has been separated by the distance 5 meters. So now let us take a point which has been observed by portion A and portion B. So with the help of axis, so this is the axis, with this axis we can give the exact distance from this observer to this point. We know that the motion is only in x direction, so we can write xa equals to xb plus 5, as this xb is distance from observer to point plus 5 meters, distance between two frames. So this is xa, and here y equals to yb. It is only y equals to yb because the observer is moving in x direction only, not in y direction or z direction, so it is only y equals to yb. Same with z equals to zb. So before going to the definition of Lorentz transformation, I'd like to give a short description on Lorentz transformation. That is the foundational stone of Albert Einstein's special theory of relativity. And with the help of Lorentz transformation equation, we can derive four equations, and the consequences of Einstein theory of relativity like time dilation, length contraction, variation of mass and velocity, n equals to mc squared. These all theories are derived by Lorentz transformation, so Lorentz transformation is very much necessary. So now we'll go to the definition. So is the definition: the Lorentz transformation is the transformation between two initial reference frames when one is moving with a constant velocity with respect to the others. So this is the initial reference frame. This 2 is the initial reference frame where one is moving with constant velocity. So in this direction, in x direction, this reference frame is moving. So here let the initial reference frames be s and s prime. So the time over this initial reference frame is t equals to 0, and the initial reference frames on the other time is t prime equals to 0, as both will have constant time and even they will have the speed of light similar. So now we will write this value: x equals to gamma x prime plus bt prime, y equals to y prime, and z equals to z prime from this given graph. And you will be thinking why I have chosen gamma in this equation, and as we know that gamma is a constant, we did this thing because when something follows special theory of relativity, then there will be time dilation and length contraction. So time dilation and length contraction occurs when something will move with greater speed, then the length of that object will be smaller. that is called length contraction, and even the time for that object will be slow, which means time dilation. So we have chosen gamma for this reason, and even the gamma is also called Lorenz factor. And some important points we should know is that Lorentz transformation will work only for the velocity which is similar to the speed of light, that is 3 into 10 to the power 8 meter per second. And in the other hand, there is a Galilean transformation which works for less velocity things like cars or speed of a bus. So finally got the equation 1, that is x equals to gamma x prime plus bt prime. We got this equation from this. When this is moving towards this direction, now we'll find the same, but this time the frame will be moving towards the left hand side. So here motion is relative, thus we can also say that frame S prime is stationary while frame S is moving with velocity v to the left along x axis. This means that this frame S prime is constant over here and it is in rest position, but the frame S is moving towards left direction, so it is moving towards this direction. So we can write x prime equals to gamma x minus bt, or we write minus over here because before we in equation 1 we wrote the sign plus and here is the minus, because the reason for this is velocity is moving towards left direction. Before in equation 1 it was moving towards right direction, in this direction, but now it is moving towards this direction, so we choose minus, or we wrote minus over here, and we get y prime equals to y and z prime equals to z, because as the velocity is moving only towards x-axis, not towards y and z-axis. So now we got the equation 2. So now we will be substituting the value of x prime from equation 2 to 1, and this is the equation x equals to gamma x prime plus bt prime, and this is equation 1. And now we will substitute the value of x prime, and this is the value of x prime. Is x equals to, here's the gamma bracket x prime means here's the gamma bracket x minus bt plus bt prime, and here comes the gamma down, add down, so x by gamma equals to gamma into gamma x minus gamma bt plus bt prime. So here we took bt over here, bt prime equals 2, and take this over this side, x by gamma minus gamma x plus gamma bt, and now we'll take out t prime equals to x by gamma b over here minus xb plus rt. This b will be cancelled with this b as well, it will come down, so it will be cancelled, so there will remaining will be gamma t. So t prime equals to gamma t minus gamma x by b plus x gamma by b. So t prime equals to gamma t minus gamma x by b. As we take out this gamma by x by b, here remains 1 and minus 1 by r square. So now this is equation 3. Similarly, we can write this t prime in this form: t equals to gamma t prime plus gamma x prime by b 1 minus 1 by gamma square, and this is the equation 4. Now we will evaluate the value of gamma using second postulate of special theory of relativity. So now we will use the second postulate of special theory of relativity, which says that for every observer the speed of light will be same, that is 3 into 10 to the power 8 meter per second. This is the second postulate of special theory of relativity. So this is the graph for it, and its position from S is x equals to ct. So this is the distance equals to speed in time. So now its position from S is x equals to ct. Here we do the formula of distance equals to speed into time. Distance is from this origin to the x, which is called x. So x is distance equals to speed of light, means which is denoted by c into time, and from S prime is x prime. Over here from origin to x prime is the distance, so distance equals to speed of light, which is denoted by c by time prime, t prime. So time for this both it will be constant. So now substituting x and x prime in equation 1 and 2. So this is the equation 1, x equals to x we got before. See, this is equation 1, x equals to gamma x prime plus bt prime. So we will substitute the value which we found, x and x prime over here. So x means ct. X means ct equals to gamma, and x prime means ct prime. So here is ct prime plus bt prime, and here ct equals to r multiplication rt prime. We took common of t outside, gamma t prime bracket c plus b. So this is the equation A. So now x prime equals to gamma x minus bt, and this the for this this is an equation 2 which we found before. This one. Now we will put the value of x and x prime over here. X prime means ct prime, and gamma x means ct minus bt. So ct prime equals to gamma t c minus b, equation B. So from B, ct prime equals to gamma t bracket c minus b. This is equation B. So t prime equals to gamma t c minus b. This c will come down. So now putting the value of t prime in A. Now we will put this value which we got from t prime over this equation. So ct minus gamma t prime bracket c plus b. Ct equals to r. So t prime means gamma t c minus b by c bracket c plus b. And here c square equals to gamma square bracket c square minus b square. As we know, c minus b and c plus b are in the form of a square minus b square. So we wrote c square minus b square over here. And here we took gamma over here. Gamma square equals to c square over here divided by c square minus b square. So gamma square equals to 1 divided by 1 minus b square by c square. So we'll get the value gamma equals to 1 by under root 1 minus b square by c square, and this is an equation 5. Now putting the value of, so now we got the value of gamma, as we were finding the value of gamma using second postulate. So we finally found it. So now we'll put the value of gamma in equation 1 and 2. So x equals to gamma x prime plus bt prime, and this is an equation So x equals to 1 by, so gamma means, so gamma got the value 1 by root 1 minus b square by c square. So we do over here, we get x prime plus bt prime, and x equals to, so here x prime plus bt prime divided by under root 1 minus b square by c square. So now in equation 2, we will get x prime equals to x minus bt under root 1 minus b square by c square. So now this is the equation 6, and this is the first Lorenz transformation equation, and this 2 is important. Now putting 1 minus 1 by gamma square equals to b square by c square in equation 3 and 4. Now in equation 3 and 4, we have to put this value over there. So it will be t, here equation 3, see, t prime equals to gamma t minus gamma x by v bracket. See, in equation 3 there is a presence of 1 minus 1 by r square, so we can write 1 minus 1 by gamma square in the form of b square by c square. So we wrote here over here b square by c square. So here we'll get t prime equals to gamma the bracket t minus x b of all c square. So we got t prime also, t prime equals to t minus x b divided by c square or root 1 minus b square by c square bracket. Actually this is x prime. Now in equation 4, now we have to put in equation 4 this value in this value over equation 4. T equals to gamma t dash plus gamma x prime by b 1 minus 1 by r square. This is in equation 4. This is over here, and now we will do the same as before. T minus gamma t prime plus gamma x prime by v into b square by c square, which is given over here value. So we will put over here, and we will get t equals to gamma and t plus x prime v by c square. So we will get t equals to t plus x prime v by c square divided by root 1 minus b square by c square, and this both are equation 7. And y equals to y and z prime equals to z in this equation 8. Now equation 6, 7 and 8 are known as Lorenz transformation equation. So this is the equation, Lorenz equation. You can only write up to this much, no need to write or find x prime. So now we have come to the new subtopic, length contraction, which is also the consequences of Lorenz transformation. So its definition is, it is the phenomena that a moving object length is measured to a shorter than its proper length, which is the length as measured in the object's own rest frame. So it means, in simple word, length contraction means decrease in length of an object which is in motion than its original length. So it's some of the points for length contraction. It is also known as Lorenz contraction, and length contraction is only in the direction in which the body is traveling. And here's the formula of length contraction. That is L equals to L naught under root 1 minus b square by c square. This is the formula for length contraction. And here's L equals to, L means length measured from an object outside the frame of reference. L, and L naught means length measured from an observer inside the frame of reference. And v equals to speed of the object, and c equals to speed of light. And derivation for length contraction. So firstly, let us take two frames, that is S and S prime. These are two frames. And secondly, we will take two rods which contain same length, and this is the rod which has same length, which is placed on the x-axis. Placed on the x-axis with coordinate for this x-axis, its coordinate is x1 and x2, and for this rod its coordinate is x1 prime and x2 prime. And this x prime is moving. This means this iron rod is moving, is velocity, and this iron rod is in rest position. So its distance of rod in rest is L naught, and the distance of rod in which is moving is L. So we can write L naught equals to x2 minus x1, and here we can write L equals to x2 prime minus x1 prime. So now we'll use Lorenz equation as we have learned before. That is x1 equals to x1 prime plus bt prime under root 1 minus b square by c square. That is equation 1, and this is in equation 2. Now we'll subtract equation 2 minus equation 1, that is x2 minus x1, and we'll get this value, that is x1 x prime 2 plus bt prime minus x1 prime minus bt prime under root 1 minus b square c square. So this bt prime minus bt prime will cancel out, so the remaining will be L naught minus Ly under root 1 minus b square by c square, as we know that x2 minus x1 means L naught. So here is the L naught, and here remains x1 x prime 2 minus x prime 1. So here x2 prime minus x1 prime means L. So here's the L. So last, L equals to L naught under root 1 minus b square divided by c square proved. So this is the formula for length contraction, and here the L means moving length, and length of means the object which is moving. It's known as L, moving length. Length of moving object is L, and this L naught is a length of an object which is in rest. So now the third topic is time dilation, and it's also the consequences of Lorentz transformation. So it defines in terms of physics, the time dilation is the difference in the elapsed time as measured by two clocks. For example, time goes slower at the ISS, lagging approximately 0.01 seconds for every 12 Earth months passed. For GPS satellites to work, they must adjust for similar bending of space-time to coordinate properly with system on Earth. So this is the rocket which carries one observer over here, and this is imagine of Earth having observer A over here. This is observer A, and this is an observer B, and this is a mirror, and this observer is looking towards this light, beam of light, which is moving up and down in a straight line. As the rocket is moving with greater speed, so the observer which is inside the rocket observe that the beam of light is up and down in a straight line. But for the observer from Earth, this observer from Earth will see that the motion of this beam of light is in this direction, from this to up, here to here. This pink is the angle which is being observed by the observer from Earth, and this orange one line is being observed by by observer inside the rocket. So the motion for observer A, which is this, A is ct, and for observer this is ct naught, and this bt means b is the velocity of the spacecraft which is moving. So now we'll take out this triangle and in right angle triangle using, now we'll use Pythagoras theorem. That is hypotenuse square equals to perpendicular square plus base square. So hypotenuse is ct is hypotenuse, so we will write ct square equals to ct naught, which is perpendicular, plus bt square, which is base square. So we'll square this all, squaring all, we'll get c square t square equals to c square t naught square plus b square t square. So c square t square minus, we'll bring this b square t square over here, equals to c square t naught square. So we'll take t square common, so t square will be common, so it will come c square minus b square equals c square t square naught. Now dividing by c square on both sides, we'll divide c square in both sides, so we'll get t square c square by c square will be cancelled out, so it will remain 1 minus b square by c square equals to is same with here c square will go and c square will cancel, so t naught square will remain. So t naught square equals to t naught square divided by this will go down 1 minus b square by c square. So t equals to t naught the root 1 minus, as this square is been removed, so root will come over here, 1 minus root b square by c square, and this 2 and as this root will be cancelled, so only t naught will remain over here. As now t equals to t naught under root 1 minus b by c square is the formula of time dilation. So thank you.